Hi, so this is the part 2 of the review. Again, you should have tried each of these problems first. If you were struggling with them, go ahead and listen to the first one and then pause it and try the other ones and then come back to them. And that'll kind of give you some practice on them, but still allow you the explanation. So for the graphing ones, we need to be able to identify A, H, and K as well as your base. So your base is always going to be what is raised to the power. So for this one, our base is 5. A is going to be out in front. In this case, if A is missing, it is 1. H is going to be whatever is up with the X, and for H, you're always going to do the opposite. So for this one, H is going to be -3. And then the last one, K is going to be whatever is at the end. So for this one here, K is going to be -4. And so what's happening here is with A being 1, we're not stretching at all. Which with H being -3, we are actually moving the graph left by 3. And with K being -4, we're actually moving the graph down. So what we can do is we can go ahead and we can create our table. So the ones we need to know for our X values are -1, 0, and 1. For your Y values, it's 1 over your base, 1, and your base. Okay, so off to the side, I'll show you just again the X and the Y values one more time. X is -1, 0, and 1. Y is 1 over your base, 1, and your base. This is how you get to your exponential graphs, but we're going to have to move them all around. So for this example, our base is 5, so you can see my Y values have 1 over 5, 1, and 5. Then what we're going to do is we're going to do our transformations. So upon your X values, you're always going to add H. H in this case is -3. So for this one, I'm going to go ahead and take all of my X values and I'm going to subtract 3. And so -1 minus 3 becomes -4. 0 minus 3 becomes -3, and 1 minus 3 becomes -2. For my Y values, you're always going to multiply by A and then add A. So for this example, we're going to multiply by 1 and then subtract 4. So we're going to do 1/5 times 1 minus 4. We're going to do 1 times 1 minus 4. And we're going to do 5 times 1 minus 4. And so when we do 1/5 times 1 minus 4, we get -3.8 or -3 4/5. 1 times 1 minus 4 is -3. And 5 times 1 minus 4 becomes 1. So if we graph those points, -4, -3.8, -3, -3, and -2, 1, we get a pretty good picture of what this exponential function would look like. But then we also want to take into consideration the asymptote. So your asymptote is always going to be y equals your k value. So in this case, it's going to be y equals -4. These are always going to match the number at the end, the k value, and your asymptote. We are going to graph the asymptote on a horizontal line, whatever that k value is. And then we can use that asymptote to actually connect the dots and make this look like that exponential function getting close to y equals -4 but never touching. Domain for exponential functions is always negative to positive infinity. Range starts low at -4 and goes up for forever to positive infinity. This one, our base is 5, meaning it's a growth function because it is growing over time. Let's take a look at another one of these. So for this one here, your A value is 2. That means it's a vertical stretch of 2. Your H value is normally up here with the X's. If there's nothing there, H is 0. Your K value is 3, meaning you're moving your graph up 3. And so what we can do right now is we actually could write the asymptote y equals 3 and draw our dotted line. We also could do our domain right away, and it's negative to positive infinity because it's left and right forever for all exponential functions. Our x values are going to be -1, 0, and 1. Our y values are 1 over the base. Now our base here is going to be 1/2. So when we do 1 divided by our base, it's going to flip our fraction. It's going to become 2 over 1. So the first one is 1 over our base, the next one is 1, and the last one is whatever the base is. So if your base is a fraction, when you do the first one, it's always going to be the flip of that, the reciprocal. For my x values, I'm going to add h, which in this case is going to be adding 0. So it's going to remain -1, 0, and 1. My y values are times a plus k. So we're going to do 2 times 2 and then add 3. 1 times 2 plus 3. And 1/2 times 2 plus 3. When we do those, we get 7, 5, and 4. At which point now we can go ahead and graph those points and connect it close to our asymptotes to see our graph. Our range from low to high is going to start at our asymptote and point up for forever. And this one, our base is 1/2 and our graph is decreasing, making it decay. So looking at number 17 here, we're once again going to take a look at our a value. Our a value for this one is -4, meaning it's going to be a vertical stretch of 4, and it's going to be a reflection over the x-axis. Your h value is up with your x. Since it's -1, it's going to be a +1, moving your graph right by 1. And your k value is normally at the end, so this one is 0, meaning it's not moving up or down at all. So our asymptote is y equals 0. My x values are going to be -1, 0, and 1. My base in this problem is 3, so my y values are 1 over 3, 1, and 3. I'm going to add h to my x, which is adding 1, making my new values 0, 1, and 2. My y values are times a and then plus k. So we're going to multiply by -4 and then add 0, which doesn't change it. So realistically, we just have to multiply by -4. So we get -4/3, -4, and -12. So 0, -4/3 is like 0, -1.3, 1, -4, and then 2, -12 is off the graph grid, but we can put our point down there. So this is what our graph looks like. Our domain is still -infinity to +infinity. Our range, though, starts low for forever and gets up until our asymptote at 0, and then never past that, and never touching 0. Looking at this, our base would normally tell us that this is growth, but because a is negative, anytime you have the negative a, your graph doesn't grow like you think it should. So it's going to end up being neither. Anytime a is negative, it's neither growth nor decay. So our last graphing example here, number 23, your a value here is -1, your h value here is going to be +2, and your k value here is +1, which means our graph is reflected over the x-axis, moved right 2, and up 1. Our asymptote here is going to be y equals 1. And our domain is from -infinity to +infinity. The x values are going to be -1, 0, and 1. My y values, here my base is another fraction. So my first one, when I do 1 over my base, I'm going to take and flip the fraction. Then it's 1, and then it's whatever the base is. My x values are going to be plus h. In this case, it's +2. My y values are times a plus k. So we're going to multiply by -1 and then add 1. And so as I do each of those problems, I end up with -2, 0, and then 2/3. So I graph 1 comma -2, 2 comma 0, and 3 comma 2/3, and because of my asymptote, I'm able to get a good graph there. My range starts down at -infinity and goes up until 1. And here's another case where my a value is negative. It means this is neither growth nor decay because the base indicates that it's supposed to be decay, but the graph does not necessarily visually back that up. So now we're going to talk about the word problems. You will be given the formulas. So the 1 plus r to the t multiplied by a for your growth. Your decay is the same thing, but with a minus sign. And then your compound interest is very similar. It's just r over n to the nt. It has those extra n's in there. So for this first one, the initial cost here, your a value is the 15,000. Depreciation means that it is going negative, so you're going to use the minus equation. Your rate here is the percentage, but we want to move that decimal over 2 spots, so it's going to be 0.12. And we're looking for how much it's going to be worth in 2011, but we're starting in 2004. So for our time, we're going to do 2011 minus 2004 to get a time of 7. So for this one, I do want to see your equations and then your answer. So for this one, it's y equals 15,000, parentheses 1 minus 0.12 to the 7th power. And you're going to take all of that and try it in your calculator. You should get 6,130.13. For the next one, we notice that these has the words compounded monthly in it, which means it's going to be this last formula, the one with the ends. Monthly means it's happening every single month, which means it's 12 times per year. So our n value is 12. The 4,500 is the initial amount, which is P in this formula. 2% is our rate, and so we're going to move that decimal over 2 spots and get 0.02. 5 represents your time in this one. So we're going to go ahead and plug in 4,500 for your P, 0.02 for your R, 12 for your N, and then 12 times 5 for your T. Now when you type this one in on your calculator, you might need parentheses grouping your exponents together. So be careful, depending on your calculator, you should get for this one 49,728.55. If you have the same setup but a different answer, something happened when you typed it in, and we can talk about those if you want to come in and ask a question about that. The very last one here, we're going to go ahead and compare two different bank accounts. We're going to do Bank A and we're going to do Bank B. Bank A does interest weekly, which means for that one, N is going to be 52. Bank B does interest daily, which means for this one, N is going to be 365. So for the first one, to figure out the amount, the initial input was the 15,000. We're doing 1 plus the rate. So our rate for this one, when I move my decimal over 2 spots, is 0.025 divided by n, which for Bank A is 52, times your time. It's going to be 10 years for both of those. So for Bank A, that's our setup. When we plug everything in, we get $19,259.22. For Bank B, we're going to use the same initial amount. Our rate is different though, so it's 2.3. When I move my decimal over, it's 0.2023 divided by 365 to the 365 times 10. So my amount for this one is 18,878.86. Which bank makes us the most is Bank A. Is more. To figure out how much more, we're going to subtract A minus B, and the difference there is